My name is Chris McGill with the American Gas Association, Managing Director of Policy Analysis. I'm going to talk to you a little bit today about natural gas and the challenges in the natural gas industry. Natural gas, our cleanest fossil fuel, if you want to view it that way, perhaps even a link to a hydrogen energy economy in the future. And there are some very good things, very optimistic things for natural gas on the horizon, but there are a number of challenges, and I wanted to try to speak to you about those also, and perhaps even take a look at the possibility for technologies in the future. The first thing, and something I mentioned before as I was speaking, is looking at an expectation for growing demand for natural gas into the future. The things I'm going to talk about, I'm going to run through these slides very quickly, are predicated on that. That is the current herding instinct. As our economy grows, we use more energy. Natural gas is a piece of that energy economy, now about 24% of what the energy we consume. If you take motor fuels out of that, it's about a third of the energy that we consume. Very, very important. However, in most ways, the natural gas industry, in terms of individual consumers, even industrial consumption of natural gas, is not changing dramatically. We annually consumed about 16 trillion cubic feet back in the mid-'80s. Today it's about 23 trillion cubic feet annually, but it's been that for 10 years. It hasn't changed. What has changed is the load that is using natural gas. Much of that today, the new consumption, going to power generation. In the United States in the last decade, over 90% of the incremental power generation built in this country has gone to gas-fired plants. It is something that has impacted the market and is going to impact the market in the future. Today, this is approximately a view of our resource or sources of natural gas. About 84% of what we consume domestically comes from domestic production, essentially lower 48 production, a little bit in Alaska. The rest comes from Canada. A very small amount comes from what was mentioned before, liquefied natural gas, LNG, maybe about 3% of what we consume today. That's a problem. It has been a problem for consumers because we are in the gas market today supply constrained. And it's shown up in the price as we pay for natural gas as a consumer. And almost at an unprecedented event in 2002, Mr. Greenspan spoke to Congress about this energy resource specifically, and the expectation that we would need to broaden our sources of natural gas supply to keep natural gas in the energy mix, and specifically that goes to LNG. Natural gas reserves in this country have actually grown in the last decade. In fact, if you go back to the mid-1980s, when natural gas reserves were changed because the gas known to exist on the North Slope was taken out of the reserves base, taken off of the big three books that were up there, the amount of gas we know, reserves we know to be in the ground today, is higher than it was then. The activity for looking for natural gas in this country has grown. We're going back to the early 1980s, there were higher levels of drilling activity, investment activity into getting gas and oil out of the ground. But we're on definitely an upward curve. We're seeing more drilling activity and more drilling activity specifically going to natural gas than we've ever seen before. 85% of the drilling activity in this country, the 1,400 or so rigs operating every day, 85% is going to natural gas targets. That changed from being more oil-oriented prior to 1990. But there's a problem. This is a production capability, the solid blue line curve, with a production curve, or a consumption curve of production, if you will, that shows that essentially prior to January of 2000 in this country, there was a little bit of extra production capability than there was actual demand for natural gas, even at peak periods. I'm probably the least technical person here today. I know my Econ 101 tells me that when you have that situation, you have relatively low prices. And that's what we had. Per unit, $2 gas at the wellhead. Today, well, go back to December, we had $15 gas at the wellhead. And that's because since January of 2000, the 2000-2001 winter heating season, which was the first winter heating season when natural gas prices to consumers hit double digits from that per unit cost basis, going forward, there has essentially been absolutely no extra. We have consumed everything that has been produced. And from an economic standpoint, that's the line we currently exist on. So that where there is any kind of demand event, any kind of weather event, any kind of supply-related event, and that supply-related event right there is this past hurricane season, you get movement and extreme movements in natural gas prices. We have, in this country, in the lower 48 states, we produce about 50 billion cubic feet per day. Prior to the hurricane season, natural gas prices over the summer had gone from about $5 early in the spring to $10, generally because of demand for electricity during a very warm summer. The price spike created by the supply disruptions in the hurricane just added to that. And we saw then an early cold weather period in December, which added to it again. We saw natural gas prices going up. And as I said before, I was talking to consumers earlier this summer about an expectation for paying 70% more to heat your home in the Midwest than they did just 1 year earlier. So there are issues with respect to natural gas. In this case, we had a period of time in late August and early September where probably 16, 17, 18% of the natural gas that was supplying the market was off the market. And that was in a tight market to begin with. So where do you go? Well, I threw this up here because, again, I'll try to talk to you with respect to the average consumer. The average consumer doesn't have a clue that natural gas comes from in the ground. He doesn't have a clue that it comes from the interstitial pore space in rock, not from a big hole someplace. So developing natural gas resources is something that just most people really don't have a handle on it. Technology has done a lot in recent years. Most of the drilling targets that we see today, that large increase in gas-directed drilling, are not going to developmental elephants. They're going to finding small reservoirs. Now, things like three-dimensional and four-dimensional seismic technology has allowed us to find these small, sinuous reservoirs, drill many, many, many fewer dry holes, develop the reservoirs more efficiently, but they're smaller. Directional drilling, you can argue, a little less of a footprint on the production side of the business. That's been helpful in some ways. But what we've created in this country is a situation where, with the limits that we have placed on development of natural gas, and I'm not going to argue whether those are correct or not in terms of land use, but this is essentially what has happened. The lighter yellow color is the production curve of a well drilled first and initially produced in 1985. It produced over the course of about 10 years 4.7 billion cubic feet of natural gas. Now that was a vertically drilled well using the production technologies and the completion technologies of the time. This is a well drilled in the mid-90s, initial production in February of 1994 in the same area, Eugene Island area of the Gulf of Mexico. It produced 7.7 billion cubic feet in 10 months. Now that's great. Technology has helped us recover more gas in place quicker. That's an economic windfall. My training is in petroleum geology, and when I used to sit at my drafting board and work on a field, I worked with producing curves that looked more like that light yellow curve. And you drilled one well, and then you drilled another, and you drilled another, and you drilled another, and you drilled another, and you drilled another. And you took your time to develop the field. And what you did is you built up over time a long production history that formed a baseline for your gas resource. Essentially, that curve has been turned up on its end. So now when a producer goes out to the Gulf of Mexico and uses the technology that is there to produce, he drills that well, he produces that well, and the geologist had better already have the next prospect off his drafting board, the rig lined up and ready to go, to replace that production that is being produced in the time that it is being produced. So much of the drilling activity that I showed you before is just keeping up with our technological capabilities in terms of getting gas out of the ground. The problem, therefore, then becomes that for AGA's view of natural gas going forward, we don't see a real perspective for increasing gas production in this country over the next 10 to 15 years. We believe that the 18 to 19 trillion cubic feet, that 84, 83, 85% of what we consume production curve isn't going to change. There are self-imposed limits that we've made political and other decisions on not permitting access to some resources. We're using technology to do the best we can, but essentially it will keep us running in place. So that some areas of the country are going to be declining in their gas production, some areas going up a little bit, but overall, over the next 5 to 10 years, that doesn't change very much. And the nature of the reservoirs is changing also. More unconventional is what it used to be called, natural gas. I call it less conventional today because the production techniques and the completion techniques have gotten to a point now where something like 35% of what we're consuming in natural gas comes from less traditional resources than it did 25 years ago. Coal seam gas, gas from Devonian shales, other places other than these traditional producing areas that are in fact declining. We have a large resource base in this country. Technology has helped us find more of it. But the question really becomes, as we look at natural gas and going forward in the gas industry, prior to 1990, coal seam gas, coal bed methane, wasn't really even on the production radar screen in this country. Today it's almost 10% of what we produce nationally. Deep water, Gulf of Mexico gas, about 6 or 7% of what we produce nationally today, not on the radar screen technologically prior to 1990. Couldn't produce in those environments. The question today is, where does the next 10% increment of gas supply come from? Even just to sustain gas supply in this country. Well, as I noted before, the resource base is large in the United States, but we are struggling to keep where we are. In Canada is essentially a reflection of what's happening here in the United States in terms of gas supply. In fact, Canada produces not 50 billion cubic feet per day, about 16 billion cubic feet per day. They already export over half to the United States. Canada is going to struggle to sustain that level of production to the U.S. What's the other solution? We've already mentioned liquefied natural gas today, LNG. There are proposals all over the map for developing LNG facilities in this country. A number of proposals are currently moving forward, 2 in the Gulf of Mexico and 2 in the Maritimes, Eastern Maritimes of Canada. Now, in the Eastern Maritimes of Canada, there is offshore production of natural gas. Of course, there is not in the eastern portion of the United States. There is a pipeline that carries that production to the Northeast, and the LNG that lands in the Maritimes of Canada will find its way into the Maritimes pipeline, and it will be one of the suppliers to the Northeast. How far can this go? It's a very good question. In the market areas, the Northeast, Southern California, Florida, been less successful at locating any of these facilities. Infrastructure issues that we're all familiar with. Other options, gas from Canada, pipeline from Canada to the lower 48 states, connecting somewhere in northern Alberta, probably 10 years away if it was started yesterday. $20 billion construction project, $20 billion to finance, $20 billion for operations and maintenance, $60 billion would be the largest infrastructure project ever in North America. That's why it hasn't been built. So, whether that's going to be that next 10% increment or not, I don't know. What I do know is there's a lot of talk about liquefied natural gas, about growing the natural gas market for its environmental qualities. And this is the kind of structure that you look at in supplying that market. Gas from Canada, LNG growing, and domestic production. And the reason I tend to show this slide to groups, even to less sophisticated consumer groups, is to try to get them to understand where domestic production fits in this puzzle. If there's a new increment of gas supply on the future, as was noted before, David, with Sempra, the current herding instinct among analysts is that it has to come from LNG. And if LNG is plan A, there is no plan B. There is no other place to go. The other part of this view then is the domestic production curve, if we let it go, if it leaves the 18, 19 trillion cubic feet per annum that we produce in natural gas in this country on an annual basis, we have nothing to replace it with. Now, that's why you're having this conference. AGA supports wind power. AGA supports virtually every alternative fuel that you can think of in terms of power generation. We think that's very, very important to the market. There are possibilities in terms of growing natural gas supply in this country. They're very real ones, LNG expansions, new LNG, natural gas from the eastern Gulf of Mexico, where currently production is not permitted, known reserves, but they're left in the ground for, well, perhaps environmental, perhaps political reasons. In the future, our view is that to grow natural gas in the energy market is going to require new sources. And the new sources are most likely to be LNG in the near term and perhaps Canada in the longer term. Alaska in the longer term. It may be that Canada actually ends up sending less natural gas to the United States over time than more, perhaps for their own needs. What can we do? Energy efficiency and conservation are paramount. Absolutely needed. Now, understand, this is coming from the American Gas Association. We represent local distribution companies who make not a nickel, not a dime, not a penny on the commodity costs. That is a straight pass-through. Whatever the increase is, it's because of what they had to pay to get that commodity. They make their money on putting gas through their pipeline system, moving it, transporting it. Our companies are talking about efficiency and conservation. It's absolutely necessary. The balance between economic and environmental value is always an issue. Diversifying sources of power to power generation, extremely important on the technical side as well as what it means to consumers individually. Encouraging Alaskan supply and LNG supplies also. Thank you very much.
Well, Sempra and PG&E were billed as conventional energy in this session. I think when David and I are done, you'll probably see that utilities aren't as conventional as they used to be. But it's still an appropriate subject for concept of commerce. And commerce in this area, this particular application is a lot of the stuff that we've been talking about for the last day and a half, we buy. Just for those of you that aren't familiar with Pacific Gas and Electric, we cover 48 of the 58 counties in California. We don't actually serve this part of Santa Barbara, northern part of Santa Barbara, and points north we do serve. I want to talk about what makes California different and why we're not as conventional as most of the conventional utilities out there. We've been part of AGA in the past, and I think there's other AGA members that are probably a little bit more traditional than we are. And a big part of it is the policy in California. This shows on a CO2 basis, global warming, climate change is an issue that's got everybody's attention. This shows that California has done a good job of managing climate change so far. You've seen the per capita amount of CO2 emissions drop 30% over this 25-year time period. And really what's done, it's energy policy. And the state of California has had a very active energy policy since the 70s. And they've had a low carbon intensity mainly because they've encouraged energy efficiency and renewables. And they've gone on more recently in the last couple of years, and they put together what they call an energy action plan, and it prescribes a loading order. So when we put these resources together, and that's my job today is integrated resource planning, we have a certain priority we put on those resources. And the things that we've been talking about here are the first layers in that priority. Customer energy efficiency is the first one. We just had, couple months ago, approval of our next 3-year budget for energy efficiency. We have almost $1 billion going into energy efficiency programs for the next 3 years. Demand response and dynamic pricing, I know there's been some discussion about that. There's been some talk, I heard people talking about automated metering systems. We have another $1 billion program going in to put in automated metering systems so people can actually respond to price signals they receive. Renewables, we've talked about that for the last day and a half. That's the area that I'm spending more and more time on. We'll talk some more about that. Distributed generation, and then when we get to the conventional energy is really the clean gas-fired plants that we basically use to make it all fit together. Customer energy efficiency and demand response and renewables don't always occur at the times you need them. So we use the gas-fired plants, the clean plants, as more load following and shaping to fit all the pieces together. And then transmission as needed to bring those plants and the renewables into the load center. The aggressive energy goals, I mentioned energy efficiency in the budget we just had approved. There's a statewide, over the next period over to 2013, we're looking at 5,000 megawatts. That's the equivalent of 10 conventional sized power plants. Demand response, we have a target of 5% of our load by 2007. State law and renewables, we're trying to get 1% additional renewables every year. And that's eligible renewables. Actually, PG&E already has, if we were allowed to count the large hydro system that we already have, we'd already be at 30%, but that doesn't count for these purposes. We're only allowed to count some what are qualified as eligible renewables, and talk about that shortly. But we're at about 13% on that basis. There's actually discussions of taking the goal of these eligible renewables, a 20% goal, and expanding it out to 33% by 2020. In distributed generation, we have a self-generation incentive program where we give out rebates for microturbines and fuel cells and photovoltaics. I'll talk a little bit about this California solar initiative that we heard from the one from San Diego and some of the other folks here. We've heard bits and pieces of this today, so some of these points may have been covered. We already have almost 10,000 solar systems connected to our grid today, small residential size all the way up into the multiple 100 kW size. This is the solar initiative that's been referenced a couple times, almost $3 billion over the next 11 years. And the intent here is to send a long-term commitment to the manufacturers. And we've heard comments about the tax credits and some of the other incentive policies that are out there and why they haven't worked. When you have a 2-year tax credit, nobody can get a factory up and running and get production out the door just on the assumption that that tax credit is going to get renewed. So the proposal here is to put out a 10, or in this case 11-year program so people can actually increase the production. The challenge in California is you start putting out the incentives, there isn't enough production out there, and we heard some of that discussion in one of the panels earlier, that the money, I think David said, the money doesn't always go where you think it's going to go. Sometimes you just see the prices go up higher. So that's one of the challenges here, and one of the ways that the state's trying to address that is really by getting a long-term commitment so we can get more factories built. And like I say here, that's about 3,000 megawatts we expect to see come out of that program. That's the intent, at least. And the discussion earlier about the incentive program, it's starting out as a capacity incentive, an installed watt per incentive of $2.80, with the intent of switching over to performance-based at some time during the course of the program. There will be workshops and things to determine how that should go. I don't think there's been a full determination on that yet. And the initial program is going to start out with photovoltaics, and it will move into hot water heating and solar thermal under 1 megawatt and things of that nature. One of the things that drives California is the Renewable Portfolio Standard. There's 21 states that I show here. I heard a number of 22 this morning, so there might be one state off here, but I can say that California has the highest standard. You'll see numbers on here, for example, New York at 25%, but their 25% includes the large hydro that we're not counting. So this 20% is still a huge number, and I think the largest number on the page. And this reflects that also. This is from another source, Union of Concerned Scientists, but this shows the type of expenditures that are expected from state funds and state renewable portfolio standard programs. And you can see California is far bigger than any of the other states. I mentioned eligible renewables. These are the renewables that we look for and we solicit on an annual basis and go out and ask for people to bring in projects. Some of them, wind's traditional, has been around for 20 plus years now. Solar, there's some solar centers out there, solar production facilities out there that have been out there for almost 20 years, but there's quite a lag on those as they're just coming around again at some of the bigger facilities. Small hydro, geothermal, biomass, and you can see the others listed here. Even ocean wave is coming up now. I mentioned we actually contract with this. That's the concept to commerce part of it. We are the commerce part. We'll contract with people. We solicit every year, and people will bring us proposals that will evaluate and look for a sort of a least cost best fit and how it fits our portfolio and what costs we see coming in, and then come up with a short list and negotiate with these people and actually come up with contracts. These are the contracts that we've signed over the last few years, and this including 3 years when we were in bankruptcy. So we've stepped up quite a bit more recently, and we'll see quite a bit more coming out of it now that we've been out of bankruptcy for a year. One of the things that we talked about in wind, and I think there's a need for some more technology to be applied to that, is the way to really integrate this into the system. We heard some discussion earlier from Clipper that it's not too big of an issue. Depends on where it's located, how concentrated it is, a number of other factors. California has multiple wind resource areas, so if we can balance those out, it probably mitigates it a little bit. But if you concentrate it in one area, it's more of a challenge because you have the issues of the volatility and the minute-to-minute changes and the variability, some of which you can forecast, as the president of Clipper said. On the longer out you go, the more forecastable it is. You just can't forecast some of the hour-to-hour and minute-to-minute changes. So there's probably a room for technology there, possibly a storage technology, something of that nature. One of the things I mentioned is there are about 350 megawatts of central station solar in the Mojave Desert now that have been down there for, I think, about 18 years. And they work quite well. And the solar is one of these things I mentioned. We try to fit our portfolio and find a least cost best fit. Solar is more expensive, but it does fit better. And this is a good example here. And this is central station solar. And one of the advantages of solar is the utility scale solar is generally tracking. And we've been talking today about photovoltaics and some of the typical roof mount things, roof mount applications. The challenge with the roof mount applications, they don't track, so they'll max out at solar noon or 1 o'clock daylight time, and they'll trail off before they get to our peak, because our peak is actually out here further. You can see from this graph here, our peak is going to be in the range of 5 p.m. Traditional roof-mounted solar is going to max out about 1 o'clock and then taper off, so at 5 p.m. it's going to be down somewhere in the 33% range. You can see if you're tracking, though, you can keep that peak on. The other benefit that I'm showing here is if you're using a solar thermal application and it tries to starts to taper off as the year goes on, you can actually use co-firing of other fuels, either natural gas or biofuels or something, so there's a benefit there. Now, one of the things I went back and modified my slides last night after Professor Lackner spoke. And there was a discussion yesterday about how you can do mass manufacturing scale and get some benefit out of that. And I think one of the questions Mike had in the audience was, were there any other applications out there today of this modularity? And this is the one that comes to mind to me. Sterling Energy Systems is a Phoenix company. They've signed a contract with Southern California Edison and another with San Diego Gas and Electric, and they're now going to build these units, which are 25 kilowatts each. So, you know, it's a unit that's been around now for about 20 years in a test mode, and they're going to go to a commercial standard, and it becomes like this analogy of the engine block. If you can get the production numbers up there high enough, you can get the prices down. For the 1,000 megawatts or the 1 gigawatt that Professor Lackner was talking about, we're talking about 40,000 of these units. But if you can build 40,000 of these units, you can get them down so the prices on a per unit basis are there. So I thought this was an excellent example of a point we heard last night. Now, the other thing that I mentioned earlier at the bottom of the list is wave power. California has a great coastline. Now, there's some limitations on where you can site things out here because of some of the marine preserves, but there is potential out there, and it's something that's being done in other places. There's research going on in the United Kingdom. There's some work going on the East Coast. In New Jersey was a test unit put in place. There's a test unit being installed in Hawaii. There are a couple projects that we've been working with in California, so you'll probably see more of this coming out in the future is wave power. Now, one of the other things we don't think about is, what else, as a utility, what else can you do for climate change and some of these other things we talked about? And this may not apply in other states, but in California, I think one of the things that came out in Clipper's discussion was you can do things with off-peak power. Off-peak power in California is much cleaner than off-peak power in a lot of other states. And we have such a low CO2 emission rate because we don't have much coal to speak of, any coal to speak of in California, with a little bit of imported coal, but it really makes a difference that you can take the off-peak power that we're getting from renewables and things of that nature and use it to do other things. The examples I've got here, the first one is a stationary diesel pump. We and Southern California Edison both filed tariffs last year to convert stationary pumps to electric, to take the diesel out, which is a big polluter in the Central Valley and a big CO2 emitter, and replace that with electricity that's powered by a cleaner portfolio. And then to extend that concept to the off-peak time period, in the last bullet here, you can take plug-in electric hybrid vehicles. And the example is, for example, a Prius has a standard battery pack in it now that's meant just to operate with the gasoline engine. There are a couple of companies out there that are converting Priuses and putting in bigger battery packs. So you charge them up overnight, and the typical commuter, typical driver drives their car a few miles, parks it, gets on a train or a bus or something, and then drives home at night. A vehicle like that, if you had a plug hybrid where you charge it up overnight with a clean source of energy, you basically avoid the gasoline consumption. And it also helps if you're buying more renewables and it's an intermittent renewable that maybe has more off-peak than you had a need for, you're actually shifting that over and getting some additional benefit out of that. The other one here, truck stop electrification, is a similar concept. There's some of these already going in up Highway 5. There's some in Oregon I know already. Truckers, when they stop for overnight, they have to leave their rig running for cooling the cabin and more often for cooling the cargo area. So truck stop electrification, they have systems set up where they pump cold air into the cabin and they have electrical connections for the rig so you can turn the engine off and take all that diesel out that was otherwise being burned. So there's a good example of a technology where it's being used to take cleaner emission standards in California and applying them to help in other sectors. Now this list is one that I originally put together to present to a group called the California Clean Energy Fund. I mentioned in passing earlier that we had been in bankruptcy for 3 years, so we came out of the California energy crisis. One of the things that came out of the settlement of our bankruptcy was we were going to spend $30 million to fund the California Clean Energy Fund. And we've done that, and we're working with them, and there's 3 venture capital firms on the board of the California Clean Energy Fund, and we meet with them periodically and talk about the types of things that we'd like to see brought into the portfolio in California, and this is an example of those type of things and the types of emerging technologies that we think would add some value to California's portfolio. And some of these we've talked about, the photovoltaic cost breakthroughs like Canarca, the renewable peaking and dispatchable resources. I mentioned the main reason we still have to have gas-fired resources coming in is we have to be able to fill the gaps. If we could fill the gaps more with renewables, we'd probably even use less fossil fuel. We talked about biomass in Iogen. One of the issues with biomass in general is it's dispersed. And if you could find a smaller, cheaper, cost-effective, in this case, gasifier, because we were going to use it for generating eventually, but something you could do it in smaller quantities, because the problem with biomass is if you have to collect it all together and truck it off to a 50 or 100 megawatt power plant, you've burned all the diesel to truck it, and the energy economics just aren't there. So if you can come up with smaller units that you can locate closer to the source, you have another potential there. Unfortunately, a renewable energy, a constantly growing energy source in California is municipal solid waste. The population grows, even though there's a goal to divert 50% of the solid waste from landfills, there's still too much of it makes it there. So if there's better ways to convert that technology to energy, that's one of the things we'd like to see also. Mentioned concentrating solar power, mentioned ocean energy. Wind turbines, this morning, that was the point I made about Clipper. We'd like to see more wind turbines at a competitive price. That's a good thing. Inverters and control systems. For the photovoltaics that we've talked about, the photovoltaics may have a 25-year lifespan, but the inverters that connect them to the system generally last maybe 10 years. So there's another area for more durable inverters. Energy storage, we talked about Pentadyne. There's an application there. I think it was either for flywheel or other types of batteries and things. Twofold there. One, for the utility scale, which Pentadyne will work for, and for wind turbines, things of that nature that are intermittent. And the next one, though, is for this issue about plug hybrid electric vehicles. You need something that's an energy-dense rechargeable battery technology. And then along with that, you need a rechargeable battery technology disposal or recycling center. I've been told that there's only one center in the whole United States to recycle the nickel metal hydride batteries that are now used in hybrid vehicles, and there aren't any for lithium ion, which will be the next phase that people go into. So there's a technology that's needed in an entrepreneurial effort that's needed. Biofuels, I mentioned earlier the issue on the renewable peakers. If you had a cheaper, lower cost biofuel, you could use that to fire a peaking engine and make it more of a renewable peaker. The other application for biofuels, of course, is for automotive or transportation. I mean, ideally, the best solution on this would be a plug hybrid electric vehicle that's running on E85 with cellulosic ethanol coming out. E85 is 85% ethanol and 15% gasoline. You'd see the biggest savings in CO2 and other factors and getting off the oil addiction if you did something like that. Now, to the last points here, we still do need gas. We still need conventional power plants to tie this all together. Dry cooling is something that's a need in California because of the water issue we heard earlier. Dry cooling is even an issue with the solar plants. The solar thermal plants are liquid cooled. So any technologies and entrepreneurial efforts around that would go a long ways. And the CO2 sequestration, to the extent that we're using natural gas and to the extent that there's still a big coal reserve out there, anything we can do in that area, I think, also has an entrepreneurial effort behind it, or needs an entrepreneurial effort behind it. And lastly here, I think we have these outside now. Looking for Leslie, yes, we do. Didn't expect you to write all these down, but I know if you're switching from being oil addicts to renewables junkies, I wanted to give you some fixes here. These links will give you more information on renewables. Yeah, I put the advertisement up front, put our 2 links on there for our small program and our larger program. But the California Energy Commission, California Public Utilities Commission, this is the Biomass Collaborative out of UC Davis, California Wind Energy Association, California Solar Energy Association, and this last one is interesting. The Western Governors Association, which I believe is 19 Western states, has a clean and diversified energy initiative. And they had a number of, and Terry, I hope I'm not stealing any of your thunder for later, they had a number of subcommittees put together to look at how they could come up with 30,000 megawatts of clean energy. And I think they came up with multiples of that. I was on the solar task force. They also had a wind task force, biomass, geothermal, a number of these things. So if you're really interested in this subject, there's a lot of great material there. And I think I'm on schedule.
Good afternoon, David Barkov. I'm the Manager of Technology Development Programs at Semper Energy Utilities. Semper Energy Utilities covers Southern California Gas Company and San Diego Gas and Electric, and I'd like to reflect a comment by Al that hopefully after my presentation that you will be able to step back and see the utilities truly are trying to be innovative and trying to change the way we've done business and looking forward into the future. I'd like to just give you a Saturday afternoon little humor. There was a story about that we can learn a lesson from the .com implosion. And the story goes, there was an eagle that was perched on a tree. And the eagle was just sitting up there relaxing, and a rabbit came by and said, gee, can I just sit there and do nothing too? And the eagle said, well, sure, of course. So the rabbit hopped onto the nearest rock and just spread out and just took a sun bath. Well, lo and behold, a little fox came out of the brush and had the rabbit for lunch. So the first lesson, lesson number 1, is that if you want it, you can stand around and do nothing, but you better be very high above your competition. And I think our utility industry is truly changing. The utilities are recognizing the need to pursue alternative energy sources and to look into a more sustainable future. What I'd like to do is talk about some of the technology drivers that are affecting Semper Utilities. We'll cover some of the programs that are important to us, and I'd like to make a few comments about the 100-year vision for the San Diego region. David Roy alluded to that particular project where it was a collaborative effort to try to paint a vision for the future. And we'll close with my comments on some of the emerging trends and concluding remarks. A few facts about Semper Energy. It was created in 1998, a merger between Innova and Pacific Enterprises. It's a $9 billion company. And you could see that we are involved in the utility business, generation, LNG, commodities, pipelines, and storage. Here are a few technology drivers that I think are important. There's obviously increasing concerns about conventional energy sources and infrastructure, global warming issues. There's a clear movement in my mind towards sustainable energy policies from both the government and from an industry and business perspective. And we need more cost-effective renewables, alternative technologies to go forward and to reach our goals into the future. I might note that from my perspective, I see greater investment by the venture capital community in the clean tech sector. That's a very good sign. When you see a lot of money coming in from private industry investing in new technologies, that tells you that there's probably an excellent market potential for this sector. I will also make a few comments about what we're doing to improve our internal operations and which might affect the customers in the future as well. Okay, here are the programs that are technology-oriented, other than the programs that were mentioned by Hal. Hal talked about a lot of the energy efficiency and incentive programs that utilities are using to promoting energy efficiency and the adoption of renewables technologies. What I'd like to do is talk a little bit about we do have an emerging technologies program where we partner with others in industry and government to demonstrate new and emerging technologies at customer sites. All three utilities, major utilities in California, 4 utilities rather, have this program, and I want to encourage you also. We have a special request for this audience. Sempra Utilities would like to install some innovative solar PV systems on our facilities. And so we're looking from you, the audience, for ideas on how to partner with others so that we could demonstrate the most efficient and promising emerging technologies in solar PV that would enable the industry to hopefully take the product to the next level. We could partner in several ways with government funding, our own funding. So if you have any ideas about the technologies we ought to be looking for to do this, or the right partnerships in putting these demonstration sites together, please contact me. Okay, I'll say just a few comments about our RD&D program. It is funded by ratepayers. The focus is on energy efficiency, demand response, reducing emissions, improving our system operations, and ultimately achieving a sustainable future. As you can see, our spending, more or less, has been rather constant at about between $10 and $23 million over the past several years. The program dollars that we are responsible for, that as the utilities manage ourselves, our utility companies, is about $9.5 million. The other funding is managed by the California Energy Commission in the form of the PEER program and the Gas Public Purpose RD&D program. This is how we break up our portfolio. This is the $9.5 million program, and it's split across various markets: gas, transmission and distribution, electric T&D. I might also note, for your interest, that we will be proposing a new electric RD&D program for our next cost of service cycle, which begins in 2008. Okay, 100-year vision. Several sponsors, stakeholders in the greater San Diego region, including the REO, San Diego REO office participated, the CEC, DOE participated. Basically, we entered into a competition with several countries around the globe. I believe that was in 2004, Tokyo, Japan. And the idea was to try to develop collectively the best vision for a community in which we all live in for the next 100 years. Well, the U.S. submittal was defined by the region around the San Diego County as well as northern Baja California. And the results of that is, I understand, we came in second, U.S. placed second. The number one winning submittal was Vancouver, Canada. So we did pretty well, but I just wanted to highlight what I think are some of the important attributes to that 100-year vision. First of all, 100% self-sufficiency from an energy perspective. Distributed generation is permeated throughout the region. Obviously, there's a huge reliance on renewables. We will be probably in a full hydrogen economy to be defined. And there will be a convergence of several technologies from wireless, transportation, and wastewater. And we'll talk about those in a second. From a transportation point of view, we envision a hybrid system where we had a lot of mass transit alternatives available to the general public, as well as personal transit vehicles that individuals would not necessarily own, but order upon demand. It's like video on demand, automobile or vehicle upon demand. But we envision a very flexible or very efficient mass transit center. Housing and buildings will be super smart in our view. using the latest and greatest with advanced materials, super energy efficient, and we'll have all of the latest and greatest appliances within the home itself. So that will be smart appliances. Individuals will have automated maintenance and diagnostics and dispatch capabilities. If an appliance goes out, chances are there's already a maintenance person who has the call order and is at your doorstep knocking on your door to fix it. In many cases, that event will occur even before the appliance fails. It will be done under a maintenance contract. There will be a total elimination, in our view, or should be, of the concept of waste. We all know what's happening to our landfills and issues about toxic waste in our landfills. What we'd like to do is eliminate all waste products and recycle everything that we possibly can. And of course, that's also true for wastewater. So we'll make more efficient use of our watering systems. We all know, it was mentioned before, I think David Roy mentioned, that we have not only a lot of energy used to move water around California in the US, but water is going to be a huge commodity issue over the next several years. And it's something that we're going to have to deal with. It's going to be the next great innovation when it comes to conservation, in my view. I would like to also just spend a couple minutes talking to you about our Sustainable Communities program that we've launched at San Diego Gas and Electric. This is our program that was developed to support the long-term 100-year vision. And what we're doing with this program is we're partnering with architects, developers, on innovative ways, more innovative ways to design more energy efficient buildings and structures in the San Diego County region. And then what we do is we come in and we design, build, own, and operate the energy system plants that serve that facility. We currently have one office building that has been completed, and it has a photovoltaic system on the roof as well as a fuel cell demonstration program. There is some discussion within our utilities about expanding this program into the Los Angeles area during our next cost of service rate cycle. Okay, I'd like to spend the remaining portion of my time just discussing with you some of my ideas about some of the key emerging trends in each of these areas here. Okay, first of all, energy supply, energy, oil recovery. There is still a lot of carbon materials located underground. All of the easy oil, the light oil has already been pumped out of the ground. Well, there's still a lot of shale oil and other more difficult oil deposits under the ground that could potentially be recovered down the road. LNG. We already discussed LNG. I won't spend too much time on that. Clean coal. It's interesting. Probably, I would imagine, 50 years ago, if took a survey in the United States and asked a government official, gee, how much oil do you think, how much supply of oil do we really have? The answer you would have gotten probably is, maybe about 200 years, right? And then about maybe 15, 20 years ago, we were hearing comments about the natural gas supply system. How much natural gas is available in the world? Well, probably 200 years. Well, we're getting a little concerned about both. Now we're hearing, well, how much clean coal do we have? 200 years, right? Do you see the pattern? It's like every time we come up with the 200-year figure, we realized several years down the road that we're completely wrong. So I would say that even though we might think we have an unlimited abundance source of coal, that resource is probably going to be constrained over the next several decades. And Hal did a good job talking about biofuels, and methane hydrates was also discussed. In generation, there is a move that has become more popular to actually develop zero emissions power plants. So even though we might have a power plant that may or may not use fossil fuels, nonetheless, the goal is it should be a zero emission power plant. Well, how do you do that? Well, there's one particular company that's California based called Clean Energy Systems, And they actually used a separation, an air separation unit at the beginning of the cycle so that you're feeding pure oxygen into the combustor system, producing very high temperature, very high pressure steam that is then used to run it and drive a steam turbine. And then the CO2 that is actually produced at the end of the cycle is sequestered. So it's our idea of actually developing a demonstration plant, perhaps in the Kern County somewhere, where we actually inject the CO2 into the ground, and the CO2 might actually loosen up some of that old oil deposits, heavy oils in the field, and then sequester permanently the CO2 underground. That's a demonstration project we're considering partner with this company. Obviously, we have heard a lot about combined heat and power systems. I think when we talk about distributed generation and we're talking about perhaps natural gas being used, obviously the standard of the industry today is to recapture the waste heat and to use that for a productive purpose. Microgrids, didn't talk too much about microgrids, but from a utility design point of view, we can imagine that there will be communities, not just in California, perhaps throughout the United States. I know of one in particular that's under development today. It's called Coyote Springs. It's a massive residential commercial development in Nevada. The problem is, it is, I think, at least 100, maybe 200 miles away north of Las Vegas, away from infrastructure. Well, how are they going to power the city? They're going to actually create a microgrid. So they're going to be self-sustaining from an energy point of view. That's actually the design goal. Now, whether they achieve that or not remains to be seen. But that's an example of a pretty interesting microgrid. My comment on solar PV. Here's my question. Can the cost reduction be maintained at 5% per year? Well, we've heard some very encouraging figures at this conference, and I'm more inclined to believe that the solar PV systems will continue to decrease in cost, which is very encouraging. Is it going to be 5% per year? I don't know, but it sounds like that the technology is certainly improving. Hal already talked about solar central thermal and wind. Well, we heard from the Clipper folks that bigger is certainly better. My last comment on nuclear. Well, and the president, I believe, talked about nuclear energy in his speech, but who wants a nuclear plant in their backyard? That might be a tough one to sell. Okay, transportation options. Here's a few things that are, in my view, will be populating the marketplace. Compressed natural gas and liquefied natural gas vehicles, mostly focused on buses, waste refuge trucks, trash trucks, and I'd like to see actually an LNG application with locomotives. As we know, locomotives rely on diesel engines that are in many cases uncontrolled emissions. It'd be really great to start replacing those with cleaner fuels. Hal already talked about plug-in hybrids, fuel cell vehicles. Who believes fuel cell vehicles will be here in the parking lot, in the car sales lots within the next 10 years? Can I have a raise of hands? Who believes we'll be able to buy a fuel cell vehicle within 10 years? Okay, handful. So that's interesting technology. That technology has promise. Obviously, very, very expensive, and the infrastructure has to be put into place. My view on fuel cell vehicles is I personally think it'll be more of a 25-year proposition. I believe that the initial fuel cell vehicles that will be available to the marketplace will be demonstration purposes only because of the cost hurdles. I'm hoping I'm wrong, by the way. I'm hoping that the big three automobile manufacturers and the Japanese manufacturers will make some incredible technology breakthroughs so that the cars become actually affordable. What about the customer side? Well, we can expect more home automation, smart appliances, we talked about that, advanced cooking systems. Somebody could be at work, could press a few buttons on their internet system, And lo and behold, a pre-packaged meal device could be ready by the time you come home. Wouldn't that be something? A new innovation with building controls. As you know, most of large institutional commercial buildings, including this university, have all been designed with traditional sensors, controls that feed into a box or computer somewhere. The problem is the building operator tends to override most of the logic that controls the building operations. And so as a result, after buildings have been in operation for a few years, the energy efficiency profile of buildings become very poor, average at best. So what's needed is a higher level interface that can take all of that information, very carefully monitor what's going on with the central plant, and to inform the decision makers or operators when a part or component is out of whack. So instead of somebody complaining, well, I feel warm, I'm going to press this button to compensate, maybe there's a problem with the system that needs to be replaced. We think this is going to be the next wave of innovation in regards to what consumers are going to be looking for in their attempt to reduce energy and achieve operating cost savings in their plants. We talked about distributed generation, I think also what we'll see is there are several companies that are developing new methods to produce hydrogen from a variety of sources, renewables and as well as natural gas. And it appears that many of these technologies will enable customers to produce the hydrogen supplies on site rather than having it trucked into their facilities. Flint did a good job covering high-speed flywheels, so I'll skip that. And let me just give you a couple of slides to think about. This is the utility of the future as we see it. We think it could be divided, the technologies could be divided into three areas. Sense and communicate, where you have several sensors, low-cost mesh networks throughout, either installed on a gas pipeline or on an electrical grid. And then we would have a think category, which basically is a warehouse of knowledge and analysis capabilities. Finally, we have more advanced tools so that users can more accurately determine what's happening within the utility itself, within the operations of the pipelines or the grids, and then be able to make decisions based on advanced diagnostics tools. So to give you an example, this might be a sample learning curve for the experience and operate. So you could see in the incubation session portion here, you actually have things like nanotechnologies, which are just getting off the ground, and some very advanced vehicle networking systems that will enable our workforce crews in the field to more effectively respond to service calls, and some growth in the robotics areas. And then, of course, here's at the latter part of the maturity area, you have ground position satellites, global position satellites, GPS, you have GIS systems, 3D displays are ready to be absorbed into the utility environment. And so we as a utility, we're actually looking at the cost effectiveness of several of these technologies that are in the maturity phase right now. Here's our vision for the utility of the future for 2020. We think that we will have systems in place that will enable us the pipeline systems to be self-sensing. We'll have self-healing grid capabilities so that if one part of the grid goes down for whatever reason, a transformer, the grid will know how to reroute itself to minimize disruption of our customers and enable our field crews to go out and fix problems, to produce a much more reliable grid. AMI stands for Automated Metering Infrastructure. California is currently considering complete transformation of meters from manual meters to complete automated meter readers. Meter infrastructure is a very, very expensive proposition. but there are plenty of reasons to consider that business case. Decision has not been made yet. We are certainly will be very supportive of whatever the policymakers decide. And what happened here? Leslie, is this a hint to cut it? Let's see. All right. How's that? One of the big challenges we have as a utility is how do you transfer all of our maps and products and facilities data into a digital format with a database to enable efficient utility operations? That's an incredibly expensive proposition, but that's, again, hopefully a future that will be realized. Okay, here are my concluding remarks. My suggestions for the future is collectively that we maintain a focus on energy sustainability. And that includes energy efficiency, effective demand response technologies and building practices, as well as implementation of renewables. We cannot forget about the needs of the customer whenever we talk about these products, and I think the panels have done a great job illustrating the need to do that. For allocation of resources, we need to ensure that there are adequate resources, not only for incremental changes with technology, but also for early stage deals. This is where the universities come into play. We need to do a better job, in my view, of encouraging more collaboration between government, academia, industry, and the investment community. And I think the universities themselves can do an awesome job of actually drawing from their own resources and enabling a very effective technology transfer capability. And it was very nice to hear that there are examples that have already been very successful here at the University of California, Santa Barbara. I know other universities have acted accordingly. And quite frankly, I think there's just a wealth of ideas at the university level, which if somehow we could figure out a way to involve more venture capital, investors, and other parties to help seed fund those, at least a demonstration of those technologies, then we might be able to help spin some of these ideas more quickly out into the marketplace. Finally, Sempra Utilities is positioning itself to be a key stakeholder in the future with the goal, of course, of achieving a sustainable community as soon as we possibly can. And with that, I'd like to thank you very much for your attention.
It's really, let me just start out by saying it's really a splendid collection of talent that we have here on this panel, which is pulled together to comment on, again, sort of in the context of emerging energy technologies, what's the picture around conventional energy companies and how do those two things intersect? What are some of those challenges and opportunities? We've got one of the leading voices and thinkers from the public policy sphere here in our state of California, Terry Tamminen. We also have, as you heard in the introduction, a number of CEOs or business leaders from Frank here in the clean coal area, down to Gary in the solar area, Maurice in the biofuels area, and Steve here from UCSB, who is both, as so many folks are, as the dean commented, 30%, I believe, both an entrepreneur as well as a researcher and an academic. So to sort of start things out, what we thought is we'd start from the public policy perspective and give Terry an opportunity to share some of his thoughts and observations about, from a public policy perspective, what are some of the challenges and opportunities here in California around building this bridge between the world of emerging energy technologies and the large conventional energy companies? Terry.
Well, thanks. I think that line, as we just saw from these presentations, is becoming more and more blurred. Obviously, these traditional fossil fuel companies or utilities are no longer oil or gas companies, but rather energy companies and innovation and technology companies. I saw yesterday, for example, I was in San Francisco at the ribbon cutting of U.S. Postal Service distribution center that the Postal Service, Department of Energy, the state, and PG&E and Chevron had partnered up to mount solar on the rooftops and over parking structures to create hydrogen to power the facility. But the thing that made that actually work was first an entire retrofit of the facility for energy efficiency, so that in fact that new energy paradigm would be sufficient to operate the facility. So all of those technologies really have to come together, and it would not have been possible economically without the public goods charge and some of the incentives that were offered. In fact, at the ribbon cutting yesterday, one of the elements of the ribbon cutting was PG&E presenting a $2.8 or $3.8, I forget, $1 million check because of the various types of programs that project qualified for in terms of rebates. But I guess my answer to your question about public policy is going to be pushed back as a question. And I'm going to ask everybody here to consider helping me answer it. And since we probably won't have time today, I'll take an unusual step and give you my email that I actually answer all my emails personally so that you can send me your thoughts. It's TT, just the initials TT, at gov, that's gov.ca.gov. So TT at gov.ca.gov. And I mean, I'm always happy to answer any emails and be involved in a lot of discussions about different things that we've heard today. But in particular, I'm trying to help the governor understand as we go into a second term. After all, he did say, "I'll be back." What are the policies with respect to energy and efficiency in that arena that are yielding the best results, and which are the ones, frankly, that are not, that we ought to modify or abandon? We think back to the effort to try to provide cleaner air with oxygenating fuels, and we mandated MTBE, and we all know what that did to groundwater. And so actually, even my predecessor at Cali, PA, Winston Hickox and the Davis administration had already kind of started a program, and I continued it, and it was continued now under Dr. Lloyd, our current head of EPA, of cross-media integration, really trying to get the various boards and departments and agencies within state government and working at other levels of government to figure out how to identify where those programs are actually working and where they might be having unintended consequences. But when we look at things like the Renewable Portfolio Standard, when we look at renewable energy credits, I mean, we've heard today about what qualifies for renewable energy and what doesn't, but obviously one of the things that currently doesn't is putting solar or incentivizing solar on individual rooftops. Governor launched his Million Solar Roof campaign, which ultimately kind of got lost to the politics, unfortunately, in the legislature, but the PUC went ahead and adopted. And so now there's a lot of incentive money out there. There's a carrot, a public policy carrot, if you will. And do we need some additional public policy refinement in terms of being able to define some of those rooftop solar installations for renewable energy credits so that we can meet our RPS standard and accelerate our RPS standard? So I think the question is, and then you look at other money that we've tried to put on the table for the Carl Moyer program. We've seen how many of the energy strategies today are designed at dealing with greenhouse gases in a increasingly carbon constrained world. And that will be increasingly constrained here in California because last June, as you probably know, the governor set California on one of the most aggressive paths in the world to reducing its footprint of greenhouse gas emissions. And the only way we're going to do that is with enlightened policy that includes both the right incentives and the right command and control policy, if you will, that's not overly burdensome. We obviously want the marketplace to help us with this, but sometimes that means leveling the playing field. So I'm sure our other panelists have a lot to add to that, but I would hope that as we go through the last hour or two of today, and then those of you that jotted down my email, you'll help me answer the question. Which are those incentives and policies that are working? Which ones need tweaking? And which ones have we not yet thought about that we ought to be thinking about, that we can either do administratively or that we ought to be looking at legislative initiatives going on into the next couple of years?
Thanks, Terry. I'm curious to hear what that email count is. Be careful what you wish for. Why don't we start from right to left and with Gary Barsley. And if you can, I think to mix it up a little bit, we're getting towards the end of the day. I think this is actually the last full panel. There are a couple of speakers, including Terry, that'll happen after this panel. But in the spirit of what I think this conference is about, which is promoting a dialogue and exchange, starting with you, Gary, I would encourage you to, in part in addressing some of these questions, ask some of the other panelists, whether it's Terry or even others that are here, their thoughts from Shell's perspective and from the solar perspective on some of these issues. So one of the questions I'll start off with to you is, in terms of, a large multinational energy company that's taken some obvious, interesting, and aggressive steps in the renewables area, what are some of the catalysts from your perspective for engaging and adopting some of these emerging technologies that we've heard about today?
Well, good question. I think increasingly a lot of big firms who would have looked at it differently a number of years ago are just seeing it as good business. And part of it is the economics. As traditional energy sources get higher and higher, like everybody's talked about, frankly, the biggest firms are going to have to pay more attention to this to stay economical, and they can see a bottom line effect. It isn't as simple as just doing good anymore, but it's good business for a lot of big firms. As a number of our speakers and Terry just mentioned, we're moving rapidly into a world where carbon is a big deal. Greenhouse gas emissions and carbon, a future that includes carbon trading, carbon credits, are going to drive some very, very different business policies. And big companies have both tremendous opportunities and tremendous exposure here. A lot of folks remember in the 1980s when we started our clean air programs in California, and there were clean air credits trading programs that started up, and there were some pretty dramatic impacts. It took a while for the markets to figure themselves out, and companies learned to not only live with them, but companies learned to prosper from them as well. There are technology companies that did well from those rules. So I think that's another part of it. People see this as opportunities as well as a big threat. Increasingly also, we're in a global world. All the speakers have talked about energy is not a California issue. It's a global problem, and big companies are increasingly global. I mean, Shell does business around the world, and so does most other big companies nowadays. And whether we like it or not, we get impacted by rules everywhere, and rules here are going to have the same impact. So I would say those are the main reasons. The opportunities, I think, are, big companies aren't as flexible or as fast moving, but what we saw today, there's a tremendous explosion of venture money and investor interest in clean tech, and I think there's some great opportunities there. When industries grow like energy is, and when it starts to mature like newer energies or clean tech, you see consolidation, you see mergers and acquisitions, and that brings all kinds of opportunities for investors. And big companies tend to do well when they can learn from small companies. They buy them or they license their technology, and I think that's a particular role the university can play. Actually, my question for Steve DeBars is, do you think it's particularly hard to work with big firms, or the university's proven that it can work with smaller firms, but sometimes big corporations don't want to work with startups. They feel it's too risky, and I think the universities have a particular role they can play as an intermediary there. Do you have an opinion on that?
Yeah, I think that's a good question. Actually, in the Solid State Lighting Center, we have 7 companies, large firms, and two are U.S. And it has been difficult to get the larger U.S. firms to engage with us. General Electric has not engaged with us, but the kind of the medium-sized companies we've been very successful at. The biggest roadblock I found to interacting with large firms is that the firm wants all the intellectual property rights. So as long as they can agree to some co-exclusivity or some benefit of right of first refusal, has proven a good way to get big companies to interact with us. So yeah, we're doing everything we can to get to interact with the large companies, but like I said, it's been about 50-50. And with small companies, it's almost always successful. They're very flexible in their IP terms. As we move into photovoltaics and the solid-state lighting center becomes a solid-state energy center, I think we'd be very interested in particularly talking to you at Shell Solar as we move into solar cells research here.
Good. I like to see collaborations happening real time here on the panel.
That's right.
Maurice, it's appropriate, since you're sitting next to Gary, an executive from Shell, even though it's on the solar side, since you talked about getting a $50 million check from Shell as part of developing your cellulosic ethanol plants. What did you guys do to build that bridge to a large conventional energy company and get them interested in what you were doing in Canada?
I was actually very much involved with that. The first meetings with Shell, they weren't particularly interested, and the only thing they really were focusing on is what is the potential for this industry. And when I started to trot out the numbers of quantity of biomass in the world and the potential for production, suddenly they realized, took a year to do it, but that's pretty sudden for Shell.
Real fast.
Yeah. They suddenly realized that this could be 10, 20, 30% fuel source in a lot of markets. They weren't particularly comfortable about ethanol from food, not at all. And as soon as they got interested in cellulose ethanol, they did a survey of world technologies and linked up with us. And it's been, it's a giant, mammoth elephant and a tiny mouse, but the relationship is good. It's on an individual basis. They look upon us as custodians of some very enabling technology. They've given us management techniques which we've never had. We've aligned our approach to project development doing the Shell way because we didn't have a way. And the relationship has been excellent. We are starting out with Volkswagen, and again, after a couple of rocky, trying to figure out where we stand, the Volkswagen kind of said, okay, these guys know what they're doing. We know what we're doing as well, but we sort ourselves out. General Electric are actually talking to us. It's in the distance, but they said, tell the world, we don't care. We're chasing sustainable technologies all over the place. So there we are, a little company, less than 200 people, finding it quite comfortable to deal with huge companies because they respect us for our technology. Someday they may try and buy us out, which wouldn't be too painful, I guess. And I'm sure for the owners, they wouldn't like that because they love their company. But nevertheless, it has worked and is working well. As far as outside investors are concerned, the big utilities don't show much interest in us, and it's very understandable. They're not into liquid fuels. But coal companies are interested in talking to us. Richard Branson of Virgin Airways and all the other things he does is interested in talking to us. So there's an incredible array of companies out there that are interested in at least, I think, in all energy technologies, but we certainly know it from our point of view. Just in a more general sense, I go to energy conferences all the time, but they're always in fuel. And suddenly today, 9 presenters, 8 of which were very good, we looked at 3 types of technologies, 3 for new fuel, 3 types of technologies for energy conversion, our savings, and then 3 big utilities. And the potential out there for things to really happen are great because the number of things that are going on, not just these 9, but elsewhere, that even the success rate is 50% of those initiatives that are taking off. All of a sudden you realize maybe the things are really going to turn around, and the odds are very good that the addiction to oil is a passing phase. So today's been a real eye-opener for me. Thank you.
Thank you. Steve, we talked a little bit about one of the issues you wanted to talk about or were thinking about talking about before the panel started. So you're going to have to forgive me because I'm going to depart from that script for a minute and challenge you to address Terry Tamminem for a second. And if you had, as a center of innovation, here in California as the head of the solid state, or co-director of the Solid State Lighting Display Center at UCSB, and a distinguished academic. If knowing that Terry is going to sit down with our good governor very soon, I'm sure, to talk about energy, as I imagine they do regularly, and you could say to Terry, if there is something in the next administration that the California public policy leadership could do, that the state could do, to help commercialize some of the technologies that you're seeing and that you're helping to develop and patent here at the University of California, Santa Barbara, what would a couple of those suggestions be?
Well, first let me say I think California actually is doing a pretty good job. Let me give one example for solid state lighting, and that is something you see every day is the LED traffic signals. California has 70% conversion of LED traffic signals due to incentives and rebates for the LED traffic signals. Just to give you a feeling for how much energy savings that is, it's 100 megawatts, which is one power plant in the state of California. And that was something that came out of the government here. It saves actually $70 per signal in electrical costs if you switch from a traditional light bulb, 100-watt light bulb, to LEDs. So what I'd say is, as the Solid State Lighting Center gets away from traffic signals and we get to room lights, we'd like to see some similar type of incentive program that California could lead, because there is no incentive program besides LED traffic lights, but we'd like to see one for room lighting or LCD backlighting where the power consumption is again dropped by factors of 2 to 5. That has been very successful, and so I'd like to see a continued emphasis on conservation, not just generation of power, but on quick paybacks, because lighting consumes 20% of the electricity. LEDs could reduce that to 10% in the future, so this is a 10% thing. So we've got to see, right now we're not there for the room lighting. I think Bern Keller mentioned it's $100 if you buy an LED light bulb today, but you can go to Costco and you can buy a wind-up LED flashlight which never needs any batteries and has just eliminated the toxic waste with battery disposal, which is now mandated toxic waste. So that was a great product too, and everybody should just, Rayovac hates us because you don't need to buy batteries anymore for your flashlight. Just wind it up and you can go for an hour. So those kind of things, I think that the governor could come up with some incentive programs for solid state lighting and its implementation. California can lead the way again, as it did with LED traffic lights, in getting this technology out of the university and out of the companies.
I'll expect an email.
Yeah.
So I'll write him an email, don't worry.
No accountability, Terry. You're just being filmed right now, so don't worry about it.